Ready? So we will do some face detection. So a lot of people think that how can I, the logic behind machine learning is you need to represent your data in a numerical way. And a lot of people confuse that, hey, how the hell I can represent a picture in a mathematical way so I can predict something. You know? So anybody have any idea how you can do that? How can you apply machine learning? I mean, you already know that machine learning is the presentation of your data in numbers, and then you will use those numbers to predict somebody. If you have the numbers, you can use the logical regression or random forest libraries to predict the face, but how can I represent this in numbers? So, sorry? The pixel is good one, but you know, in pixel, that one is going to be in pixel in, let's say, 94 by 94 pixels. There are a lot of ones and zeros, and this one is also going to be a ones and zeros. So what's the difference between these two pixels? How can I know that? And how can I know that there is a face?
Is there any shape?
Huh?
Reference points.
Sorry?
You're going to use reference points.
Yes, that is the right algorithm. So in order to find a face, we use the difference. So this is how machines actually find a face on a picture. So assume that this is your eye. I mean, this is a one of the really close one. And the machine is looking for every single pixel and trying to know that where is the light is goes, right? So at this point, this is brighter. This section is, darker. So machine actually trying to find out the relative to the other pixels. So it can imagine what it look like. And then finally, see that, okay, this is where it goes dark and this is where it's bright. Finally, finds an image something like this for itself, okay? But this still looks like an eye. So imagine, look here, brighter, and also there are some lines. That is a proven face detection method. And luckily somebody write that code for you. OpenFace is a Python library, so you don't necessarily code all these things by yourself to find a face, but it is how you can find. So this is the similar thing in a little bit large scale. So as you can see, there are ears and also eyes, so and also nose. See that it's still detectable even if you are looking for only grayscale on ones and zeros. So that is how machines are trying to find the face. And also there is a mathematical representation of face. So there are 128 points in a face. Remember the passport photos? They are taking the picture from the very straight. That is because they would like to see the old 128 points on your face. This is the representation of that model. So they are seeing that, hey, this guy, who is this? Bill Fallon, have this numbers at these locations. So they are mapping your face to a model and then coming up with a number. So this is the 128 points of a face. So they are looking at the brightness and darkness of your face at all these points. And this is your face. So this is where they found your face. This is the face detection, by the way. It's not the finding the right person. We're not that point yet. So this is just extracting the data. So we took the picture. So the problem usually is this. The face doesn't have to be looking directly, right? Sometimes it's looking from an angle. That means it's not as straight. So, but the machine needs to make it straight looking, right? So even if it's an angle, it finds the face and it shifts a little bit to make it straight looking. So as you can see, this is a little bit broken. I mean, it's not exactly the same picture, but it's still okay because we need to see that this is the face and this is the 128 points. So I can, by the way, in the movies, they have Hollywood really have a creative voice and to find out, these things. But it's still possible to get this fast. It doesn't necessarily have to rotate all the pictures on FBI movies and find out finally a face. No, it's not. I mean, all the faces are already in the database. Whenever you have the 128 point, you can easily find that number. You don't necessarily rotate all the database. So that's a different story. But here, so I have 128 measurements, and I learned that this is 128 points of Will Ferrell, and this is another one. So it's supposed to be similar to each other if you are talking about the same person. And then we will put them in some model. So this is your model. So remember, we were trying to come up with the numbers. This is the numbers. So I did this for you, and I will share this, comments with you guys. So the OpenFace library, it's a Python library. It has good already picture. What's that? Codes will help you to find the faces. So, for example, this command is find faces in picture. It's a nice example to help you to find a face in a picture. So let me show the picture, and this one is easy. This one seems, and again, easy. My pictures are easy to find. So this one seems a little bit angled, and as you are human, you can easily detect that there is the face, but machine have no idea whether the face is right here, or right here, right? So it needs to find this section. So it's actually doing exactly the same thing, just like we did. So it is CH1. Let's try that. CH1, but under what? Chat submit. Okay, so the algorithm is running and hopefully bring me the face. Look, so we have the face. Finally, we are in a position that we can extract faces from all the images. So that's what we need. First of all, we need the faces, right? And then we're going to use the training algorithm, which is, again, OpenFace library, to align the faces. Okay, this actually aligns the faces for my proper representation. Remember, I need to have the front-looking version of your photos, and then this command is going to run and generate image on the for these guys. So at this point, we have the images for me, and this one is going to generate the what's that? Embeddings. Okay, so it's going to generate the data that I need. Actually, it's right here. I don't necessarily run that. So this is my people: Obama and John Donne and Chad Smith, Jimmy Fallon, Lionel Messi, and Will Ferrell. We actually collected I get these pictures from the internet. I didn't get their passport photo. So there are different photos. Of course, Obama's photos are high resolution, but Chad Smith and all these guys, they don't actually, necessarily be there. So this one actually the easy one because it has a different background. It's easy to detect at least the head, so you can approximate. But this one doesn't seem to look an easy one because the background color and also the face color are almost the same. So those are challenging ones, but it's still doing a good job to find the faces on these pictures. So we finally did the this code, analyze and come up with these numbers to represent the individual. So remember, each individual, Barack Obama, John Donne, Lionel Messi, they have 4 pictures in each folder. And if you look at the first 4 are actually for Barack Obama, you can see that this is 19, 15, 18, 18. But look at mine, 24, 21, 23. So these 4 of them seems similar, but these 4 seem similar, and these 4 of them seems close to each other, right? So it actually, in a way that everybody's face has different numbers, almost different, slightly different numbers. Of course, we are just training with 4 images, but if you train with hundreds of images, you can get a better result. But for the sake of argument, this is a good approximation to distinguish people from each other. And I think the last one belongs to Will Ferrell. Let me actually look at it very quick. So where's Chad? Yeah, well, Will Ferrell is here. Where's Chad? Chad, undermine. So let's take a look at them and see that even if they are very look similar to each other, but on machine side, so these are chat for chat. Look, the numbers for chat, and Will Ferrell still, no, it's not same. It is still different. So the beauty of machine, they are not looking at the whole picture. They are looking at the some points if they are similar or not. So Will Ferrell and Chad Smith, they have some different points on their faces. Even if it's hard for us to distinguish, because when we look at the people, we usually look at the whole. We don't look at exactly this point to identify the people, right? So that's why they look like exactly the same for us, but for machine it is different. Okay, so we have this command helps us to generate these things, and at this point we are actually in a position that we have the representation of face representation and also our classification. So this is going to generate your classifier. It's a binary representation of your data in order to fast access to data. So I'm going to use this to predict some of the faces. So for example, I will use not exactly the same images. Of course, I am going to use the different images. I have my 5, 6, 7 right here, okay, to predict. Okay, let's use and Jandan 5. Let this guy to classify who is this. It's just a warning, but at the end of this command, we see that it is successfully predicting this is Candan Bölükbaşı. See? And let me try for the 7th. Remember, it was dark a little bit, and I had my white shirt and still can predict. Let's try Candan 10. It is Lionel Messi. So our mathematical formula is working right exactly with it. It was a tricky question. I actually named Lionel Messi with Candan. So to trick that, I mean, if you're looking at only the name, I need to know that. So actually it's a Lionel Messi photo, but it's named by me. And still the algorithm is saying that even if it's saying Candan, it is Lionel Messi. So see that it is working, it is proven. So that is good, but we have a better thing. So we need real-time analysis of these things, and I have a good script for that. So let me quickly explain what is this, and then I will run that and show it to you guys. So exactly the same thing. What I did is I generated labels. So this is exactly the same step that I've generated, and I imported them as labels. So these are the known faces, known face names. And these are the face encodings, 128 points. And this is our classifier, the binary of the classifier. And this is just the shape predictor. So when you're working with OpenFace library, you need to install dlib. Dlib stands for the shape recognition. And this guy is detecting the faces or maybe even shapes depending on some of the models that are already being worked on it. So for example, if you're talking about face, that 128 points is embedded in this thing, okay? So if you are going to do the vertex approximation, there's another binary that helps you to predict the shape, okay? So I use that, and also in this case, I'm going to take picture from webcam, and this library will help me to find the face on that picture and also convert it to the encoding, and then we're going to look at our classifier. So this is the network model, and it's required for OpenFace again, because this is, remember, when we have 100, small faces, we need to shift it, align it to the right position. So that is the binary stands for that. I'm going to use a 96 dimension image. So these are a few libraries I need to import in order to make this thing work. So there is one library really important for this one, CV2, which is OpenCV cross-validation. That's an important one, which also have a lot of image libraries. It is going to open my video capture device, which is webcam. And let's take a look at the main function. It is going to take read the video capture and get an image and process this image by looking at the face recognition and finding the face. If the face infer is the finding the face. If we find multiple faces, we are going to put it in a, assigned to this one. If it is one, only one person, it's not a multiple person. And then we're going to show that. So let's run this and see how it is working and what it's look like and what's it's doing behind the scene.
And where is the video?
Huh?
You have video, so just can you run the video for a second so we can see what are
Yeah, exactly. This is what we're gonna do. That's the real demo. It's not a video. Can you turn on the light, please? Because I need the light. I need to show my face to the webcam.
Okay, so you are taking the
Yeah.
from that.
Yeah, exactly. So where are we now? I think this is not the right place. I need to change directory to examples, and that's where I have the webcam. So, and in a second, I need to see my webcam is activated. I see that, but you can see that. Now it is doing and saving an image under this directory. The face recognition, sorry, it's not examples. This frame is being updated continuously. So again, see my head is changing to other directions. In order to see that in a continuous manner, I am going to open it in a browser. I have a small HTML document that can help me to, show the image. So as you can see, it can recognize me. By looking at the prediction. And let's find some other people. Can somebody come to next to me? Easy one. Patrick, can I get you here, please? Okay, come on and let's show up on the camera, please, in order to show that we are not doing any fake. So you look like Lionel Messi
Nice.
or Jim Fallon. I think it's a bad estimation.
Oh, Jimmy Fallon. No, that's good.
It's supposed to be. I think I have a code problem here, but anyway. So let me show actually real Lionel Messi here. Maybe it's really hard to detect on the phone. There we go. We can detect Lionel Messi. And who else? Actually, let me search for Jimmy Fallon. What's that? Chat and Jimmy Fallon. Yeah, Obama is also fine, but I have a better image that is really going to be challenging. So, can you guys tell me which one is Jimmy Fallon? No, right? But let's see if our algorithm can detect them. Not bad. We have Chad Smith here. Come on. Yeah, there we go. So it is really hard for us to detect when they are in this position. See that? So they are really similar, but still we can, the algorithm can detect because the points that represent these two guys are different from each other. So that's why. And by the way, maybe you guys are considering why they are taking a passport photo without glasses. So take a look at my picture and see my eyeball here. So it is actually a little bit in than its original location. See that? Because this is a glass that breaks the light. That's why the position is not exactly the same place. That's why in the passport photo it has to be without glasses to find out the exact location of your face encoding. So.
Take out their glasses, what happens?
Oh yeah, let's try. Oh, I think it is stopped. Let me try. I need to put my glass back. Yeah. So actually, in order to not run forever. So by the way, behind the scene, we're logging. See that Chat Smith with the confidence of 36, 38, whatever, and John Donne. So it's not 100% confidence because our algorithm is not optimized. We just, do it quick and dirty. Yeah. So let me remove my glasses now. Still, it says John Donne, right? I can't read, but it's supposed to be. Okay, yeah. So, lastly, this is an easy to bypass algorithm, of course. For example, if you are looking at only the face of somebody, I can easily say that I am Barack Obama, right? Let's see.
Can you search for Sachin Tendulkar?
Huh?
Similar face.
Let me actually put this in front of me. So here, if I were reading a Barack Obama mask, I can easily bypass this algorithm because it is not looking at nothing else but only the face. So that's the idea, and this is how you can, even if your data is not a bunch of numbers, you still can convert them to in numbers and use them. So all the image recognitions, all the speech recognitions, and all those things are actually finding a way to represent their data in numbers, and then use these numbers to come up with some model that works for them to predict the other similar things. And that is how you can do. So maybe you guys heard that there is an application which is called Not Hot Dog. Have you ever heard that? Not Hot Dog is an application. You can, point your camera to an object. It is telling you it is either a hot dog or not. So can you tell me how can you write this kind of application? So think about that. There is an image, and hot dog, probably it seems like a curve. And so you can come up with a similar model that estimates the curve on, remember hot dogs, it's a brighter on the upper corner and darker on the lower edges. So you can write this similar model, look like this one. Actually, the guy is actually doing exactly the same thing to, to find out the representation of hot dog, just like this one, and using exactly the same library. So he's just changing the shape source of the algorithm and then using it for hot dog. Of course, running on an iPhone, it's challenging. That's the beauty part, but that's how it works. That's all for this moment.